Welcome, admitted students. Congratulations on your admission into UC Berkeley, and thank you for your interest in physics and for learning more about the physics department. The way today's agenda will work is first we'll have some introduction of our panelists. Then Anna and myself, we're the undergraduate major advisors in the physics department. We'll just give a brief overview of the department, just about 5 minutes or so. And then really it's going to be open for you all to ask questions. So we have 2 students here. And let's start with introductions. I'll just mention again. So my name is Kathleen Cooney. I use she, her pronouns. I'm an undergraduate major advisor in the physics department. So students come to us, both recently admitted students, intended physics majors and declared physics majors for help with and support with academic planning, for questions you might have about policy and for being connected to resources, community, to start with some of your grad school or career planning as well. So I'm Kathleen, and I'll pass it over to Anna to introduce herself.
Hi, everyone. Welcome. My name is Anna Hilke, and I am the other undergraduate major advisor in the physics department. So as Kathleen said, we're really just here to support students and kind of walk you through the program, answer any questions you have. And so happy to see so many of you here today. And I'll pass it to you, Rahul.
Hello, my name is Rahul. I use he, him pronouns. I'm a 4th year physics major, at Berkeley. So it's nice to meet all of you. And then I guess Katie's the last person that's gonna go.
Hi, I'm Katie Griffith. I am a graduating senior, woo! But I'm also a transfer student. So if you have any questions, if you're coming from community college or potentially re-entry student, I'm a little older than most undergrads also. So ask me anything.
And to start off as well, if Rahul and Katie want to just mention anything you've been involved in, either student clubs or research experience, just to give students a sense for that, that would be great.
Sure. I guess I can say. So in my time at Berkeley, I've been pretty heavily involved with the UC Berkeley Society of Physics Students. So as a sophomore, I was the outreach officer, and then I became the vice president, and now I'm the president of the club with an amazing Erica Hathaway. Also, I guess on the research front, my research is kind of in theoretical quantum information science, condensed matter, and AMO. And I've worked, and I do that work in Norman Yao's group here at Berkeley. I've also worked in a high energy experimental group here at Berkeley as well when I was a 1st and 2nd year.
I wasn't really involved in clubs. It's a little harder, I think, as a transfer student to feel connected, but there is a transfer course. If anyone's a transfer, I highly, highly, highly recommend Physics 153. It really helps me develop study groups, and since you guys will probably have some in-person options, you'll actually be able to make connections this coming fall, which will be great. So if you're a transfer, definitely get into that. And as far as research, I actually was able to get research the summer before I came to Berkeley through an REU program, which is called Research Experience for Undergrads. That was in Rochester, New York. So I came with that to Berkeley. I applied for a thing called URAP, which is an undergraduate research apprenticeship program. And I got into a neutrino physics group through that. And then the next semester, I got into a condensed matter group as well, just professor contacts. Like I knew a professor from going to office hours a bunch, really was how that went. But even after all that research, I actually decided not to go to grad school, and I'll just be working after. So yeah, that's what I've been involved in at Berkeley.
Great, thanks so much. And as I give a brief overview of the physics department, Anna Hilke will post in the chat a few links that you might find helpful if you want to bookmark them, just about our curriculum and some supplementary resources. And then we'll kind of label and send some resources throughout the session as we're answering questions. So just a very brief overview. In the physics department, we typically have about 320 majors. That number can vary year by year, but that's the most recent number. For transfer students, the cohort of physics transfer students is usually about 40 students intending to major in physics who come in their junior year as transfer students. As Katie mentioned, and transfer students will be reaching out to you and four-year students as well, just with resources and emails. So if you see emails coming from myself or Anna, just take a look for some resources and feel free to reach out during the summer if you have questions. But one thing we'll stress up front is you want to make sure you're on the intended majors email listserv. So you should start getting emails by late June. If you don't, feel free to reach out to us just to make sure you're on that list. It kind of depends on what you checked when you were admitted. And also, as Katie mentioned, the Physics 153 class is something you really want to keep your eye out for if you're a transfer student. And she was a transfer mentor in that class, and it's really just a great class that introduces you to a lot of community, a lot of resources, and some opportunities for mentorship and involvement. And so we'll outreach to you about that class, but just to kind of put it on your radar. And for all students, again, Anna and I are a great first point of contact. As advisors, if you end up having any questions specific to physics or even outside of physics, and we can kind of connect you to the right resource. So we encourage you to reach out to us in the summer or as you're deciding or whatever might be most helpful. So as I mentioned, we have about 320 students, about 40 each year that are transfer students. A brief note about prerequisites. So these are for four-year students, because if you're a transfer student and admitted, you most likely completed it through your sequence in community college. So typically students in their first semester take the Calc 1 class. In your second semester, you'll take a Calc 2 class, and you'll take the first course in our physics series. You'll either do the 7 series or the 5 series. The 5 series is sort of an honors version of the 7 series. So it's for students who have a pretty extensive physics background. And this stuff is all in the website that Anna's posted, but it's just to kind of give you an overview up front in case you have questions for our students as well. So in that second semester, usually you're taking Calc 2 and Physics 5A or 7A. And then in your third semester, you'll take a multivariable calculus course alongside 5B or 7B, and 5B they both come with lab components, some built in, some are an extra class. Then you'll take a mathematical physics course in your fourth semester, and you'll take the third in the physics introductory series. So either Physics 5C if you're in that honors series, if that's the right fit for you, or 7C if you're in the other series, which is still adequate foundation. They're just a little different. If you have questions about that, Rahul could probably help answer them as well from the student perspective. And this is there's also a course called Physics 77, and that's a recommended course for students. And again, our student panelists could help you talk through this. It's not a required course, it's a recommended course if you don't have a programming background. A lot of programming skills, especially Python, are really helpful for physics research if you're interested in getting involved in research opportunities. And also it has an overview of other kinds of programming skills that are helpful for research. Python also shows up in a few upper division courses. So if you don't take this course, you're probably going to want to take advantage of our Python tutor and maybe also do some of like self-paced Python stuff or take one of our student-led courses on Python. We can talk more about that. In terms of upper division courses, just a brief overview, there are 8 upper division courses that you have to take. So if you're a transfer student, you kind of hit the ground running with those courses, although you can kind of take a refresher course on mathematical physics if you think you might need that foundation in Physics 89. You can take that if you'd like, but your Math 54 would take care of that requirement. So for the upper division courses, there's 8 requirements, 7 of which are fixed. That includes 2 lab courses and some other courses we can talk about more detail as the session goes on. And then you have 1 flexible elective that has to be an upper division physics course, but you can choose which one. Something else I'll mention is you can waive out of Calc 1 and Calc 2. If you get a 5 on the AP Calculus a BC exam, you can waive out of Calc 2. If you get anything else, like if you get a 3 or higher on the AP Calc AB exam, or lower than a 5 on the BC exam, like a 3 or 4, you would only be able to waive out of Calculus 1. If you've taken community college courses that are articulated on assist, you can also waive out of math requirements through that. And then the other things we just wanted to mention are really take a look at our physics student organizations. Anna will post a link in the chat if she hasn't already, that just kind of describe the different ways to get plugged into community. Rahul can talk a lot about the kinds of events that the Society for Physics Students hosts and the different kinds of mentorship opportunities involved in each group. And there's a lot to choose from, and it's a good way to kind of get plugged into community, and to also kind of hear about the sort of wisdom that trickles down from different students at different points in their academic careers in those groups. And so, yeah, the mentoring programs, also research opportunities and tutoring resources and advising resources. Something you'll want to just know exists when you come in is that we do have these tutoring resources. We have mentorship built into programs and advising resources as well. And then we can talk about research opportunities a little bit as questions arrive. Okay, so I see a lot of different questions have come in. The first question, can you take a mix? So we can kind of jump in or hand off questions. So you can just kind of casually ask questions in the chat and we'll answer them for you. Can you take a mix of the 2 physics series? That's a great question. So the 5 series, like I said, is an honors version. You can seamlessly start with the honors version with 5A, and then you can seamlessly make the jump into 7B if you find out that's too hard. 5A is really hard though, so you really do want to have a physics background if you want to try 5A. So you can do that pretty seamlessly. If you start with 7A and mix and want to switch into 5B, you do have to take like a little bridge course for 1 unit. It's called Physics 49. So that's a little bit less seamless, I guess, but still doable. It's just a 1 unit course. Switching after you've done 2 courses in a series is a lot more complicated and not recommended. So that's sort of the answer to that question. Is there anything in particular from lower division courses or content, whether it's physics or math, that you would strongly recommend to brush up on for transfer students to better prepare? So I'll let student answer, take this question.
Yeah, so I think if you can take Physics 89, it's supposed to be, you know, it's like linear algebra and differential equations for physics, supposedly. But as a transfer, I saw a lot of new stuff in there, first of all. So that was important. The main thing that you end up using an outrageous amount is Taylor series and sums. Know how to deal with those in physics world also, and how to, yeah, kind of, it's almost like you're doing physics math. You're not really, so it's almost like you don't need to know the full rigorous math as much as you need to know how the physics people are going to tricks to take limits in certain ways and make it work. So it's not necessarily something you can really get from a pure math course. I don't know. Maybe you can, but I think that it's important to maybe refresh that kind of stuff. And then if you can take Physics 89, it's definitely super helpful to be introduced to the kinds of things you'll see in Berkeley courses where you maybe didn't see them at your community college at all. So.
Yeah, I guess maybe I can supplant this a little bit, just because so I'm also a math major here at Berkeley, and I would say that the way that like math is used, at least in like the upper division courses, is kind of distinct from the way that like math majors typically use. It's not actually different. It's just kind of like in physics, in math, you want to like prove everything that you do, and so a lot of what you get in courses is like a tour of like, you know, what type of math is out there in the world. But in physics courses, you only focus on a few types of math, but you use those things constantly. So I would say maybe to kind of to brush up on the Taylor series point, like I would just maybe do like problems from like some mechanics books where they explicitly have you do Taylor series. And I think if you really get good at doing those like few problems, then you'd be super well prepared for the upper division.
And just a quick note on Physics 89 for transfer students. What some students do, because you've already taken a Math 54 equivalent, so you've already fulfilled that requirement if you're a transfer student, some students take it pass, no pass, and some look into taking it in the summer. So once you're admitted, you're eligible to take summer classes. You do have to work it out, see if it works with your finances. But some students take 89 as a little refresher. If you read the course description and it seems like a good refresher for you, you can take it pass, no pass during the summer. It will be remote. So that's sort of up to you where you're at with your sort of Zoom fatigue and exhaustion with that for the summer. Or some students take it in the fall. Pass, no pass, and some students don't take it depending on where their background is. So I'll just make a note about that.
Really quick, I just want to add, because that question also asked about physics along with math, and I didn't notice that at first. We've been finding that a lot of the gap for transfer students is actually in 111A, which is the lab class here at Berkeley. And so if you also, I think this has come up with, if you take the 5 series instead of the 7 series, you might be at a different place for 111A. So if you've never seen a breadboard or circuits of any sort before, whenever you take 111A, it could be your second or third semester as a transfer student. You know, maybe look into refreshing or learning for the first time a little bit about building circuits. And that's probably further along for most of you, but just be aware that I think that there are some issues with preparation for 111A, both as a transfer, but also as whether you take the 5 or 7 series. There's been some issues coming up. I'm in the lab committee, so just be aware of that also.
In terms of the next question, and I know that someone had, Julie had her hand raised as well, so we're kind of going to go back and forth between chat and hand raised. So we'll do a few of the questions in the chat since they're coming in quickly, and then I'll defer to some people with their hands raised. For this class, for the question about if a course has Physics 77 as a prereq, can you use CS 61? The thing I'll say from the advising perspective is that with a prereq, like with a question like that, you'd probably want to end, there's nothing in the system that's going to prevent you from enrolling in the course, but if Physics 77 is enlisted as giving you the foundation for that course, you're probably going to want to check in with the professor about it. Students might have more insight into whether they think CS 61 would provide an adequate foundation for courses that that entail Physics 77.
Yeah, sure. I can say something about this. So I think if you take CS 61, the CS 61 series, you're more than prepared in terms of like how to program. Like you will learn how to program way better than you will in Physics 77. But the advantage of Physics 77 is that they'll teach you numerical methods for dealing with physics type problems. So an example of this is like a Monte Carlo method. So like one way to estimate, like, I don't know, the area of a circle is by throwing points at a square and seeing, you know, like, and only keeping the points that are distance 1 from the center. So you'll learn these sorts of things in Physics 77 that, you know, may be valuable in the course that lists it as a prerequisite. I will say, and I don't know if the advisors, if this is okay to say, so please cut me off if the advisors think this is not kosher. Prerequisites are a suggestion. They are not strictly they are for your own benefit that they are listed, and no advising benefit beyond, like, there's no requirement beyond that. You can take any course even if you don't have the prerequisites for it.
One caveat to that, it is true that the system won't prevent you from enrolling. One caveat is for the foundational courses, there's more cases than not where students don't finish their physics series and they take an upper division out of order without having finished their physics like 7 series or 5 series first, or they don't have the math prerequisite for the 7 series course. Like those you do want to especially pay attention to, and they're always pointing to some kind of skills that you need. So they're not, you're right, you can enroll in the system. We might not know about it if you don't see your advisor beforehand. So, you know, some students do that if they think they know it from something else, but you do have to fulfill a lot of those foundational courses for, you know, the major declaration. So you do want to check in with your advisor about getting that done at some point. And also you have to, and also like a lot of students will think they can take things out of order and then they fail the courses because they really do build on each other. So just tread with caution with that. But sometimes I think students can discern and flexibly do that, but just know that they're also there for a reason, especially the foundational courses.
Yeah, I just to
No
you know, not perjure myself, I want to make sure that, like, again, the prerequisites there are for benefit for you. Like really, like, you know, like they tell you these are kind of the skills that, you know, you are expected to know before you enter the course. And the only good way to get a sense as to like how strictly those things should be enforced is by talking to the professor, I think, or the advisors.
Great, so I see questions are coming in quickly, so we're going to kind of keep going through them. What constitutes a suitable physics background for the 5 series? Students might be able to, maybe, yeah, students might be able to.
Yeah, sure. Suitable, I would say, for the 5 series, so you really just need a suitable background for 5A entering into Berkeley. So for that, I would say knowing calculus well and feeling comfortable with the calculus that you learn in like AP Calc is important. sort of at a conceptual level. I don't think you have to do very like hard derivatives or like integrals or anything like that, but they use the concept so regularly that it's you should really have a good foundation in that. And it's good to have seen physics before, to have like taken a physics class before, like even like an AP physics class. Yeah, I would say 5A is a very hard course. Even after taking the entire physics major, it's up there in terms of difficulty.
So I'm going to combine, I got a question, a private message. So the next one is, what types of majors and minors do people do with physics? And also someone said, is a doubling with physics seem doable, or is it too tough for students to do? So students, whether you double major or you have friends who do majors and minors that are common, I'll let students speak to that first as well.
I think the most common double major is astrophysics and physics. I have a ton of friends doing that. You get an extra semester so you can hang out and take more classes if that's your thing. So that's super doable because there's a lot of crossover with requirements and electives, I believe. I know, I'm sure Rahul can speak on math, but I also want to point out, I have some friends who have done some interesting minors. I know a guy who did public policy minor. Just took some summer courses because it just filled those, he just did those, which was interesting. So there is ways to do it. And you get a few more, like there's unit caps that you can get more units because if you have a minor and things like that. I personally just did physics only because as a transfer and then COVID and stuff, it just wasn't realistic for me to do. And I just wanted to focus on research and my career afterwards. So for me, it's all about prioritizing where you want your time. My 153 class, who always talked about how she, got all A's and pushed herself academically to be in lots of organizations and things, but then wasn't super focused on research and then didn't get into the grad schools she wanted at the end. So I just want to point out that, what you prioritize, it doesn't necessarily have to be academics to be in research, to be super involved in your community, or whatever you actually want to get out of Berkeley as a whole. And I don't have a minor, but I personally started taking a lot of electives in energy and resources and environmental science and things like that, which was super, just for me as a person, very beneficial.
As far as, yeah, no, that was, I think Katie hit a lot of great points. So just to answer quickly, as far as like logistically doing other majors with physics, my favorite part about the physics major is that the requirements are pretty minimal in terms of other majors. Like, I think each requirement is kind of daunting, is the thing with physics, but certainly at the level of classes, you can certainly take it, another major. Whether it's in, a student's bandwidth to do, another major is a different question. And also whether it's advantageous for their future goals is also a different question. But yeah, if you want to do physics in another major, that's certainly possible, I would say.
Yeah, and just to reiterate something that Katie and Rahul are beautifully pointing out, it's all about your academic and personal goals. So if you have a goal to get into grad school, research experience is really, really important, and that takes up a lot of your time. So a double major, unless you have another reason for doing it, might not be the best option for you. If you're, the college is also, the College of Letter Science is also very much emphasizes that a double major, you really have to check in your reasons for doing it, because a lot of times it can make things a little more inflexible for you. So if you really want to take certain classes in a different major, a minor might be better. Minors are more flexible, or you might just want to take the certain classes you want to take and not be locked into a major. So really think through why you'd want to do the double major. Certainly it makes sense for some students, and sometimes it keeps doors open for students or things like that. But sometimes taking the courses you want gives you a little bit more flexibility. And that's something to keep in mind as well. In terms of other, yeah, so math is common, astro is common, as I said, and then some computer science is common too, but those are probably the most common ones. Some people do like a minor in computer science. to have some programming skills beefed up alongside their physics major if they might want to, especially if they might want to pursue careers after.
Also, the data science major has just, or minor, has become pretty popular among physics students also, especially astro. It's very helpful, apparently.
So this next question is logistical for, and then we'll go to, I think, Julie, who was raising her hand before. We'll skip over her then. For a math minor with physics, would we have to take both 89 and 54? I think that's listed on the, math department website. It would be a question more for math, because you're basically asking math if they would accept 89 if you're majoring in physics and minoring in math. So it's more, it might be on the math department's website if you just search UC Berkeley math department and kind of look at the requirements for the minor. Or you can reach out to a math advisor if it's not clear on their website. I don't know offhand. I think it's interchangeable if you're a double major on the math side, but and on the physics side too, actually, if you're a double major. But I don't know for the minor, you'd have to check it with math if it's about getting that excuse for math. Julie, right, I'll let you unmute yourself since you had raised your hand before.
Sure. Hi. Thank you, Kathleen. And I just have a question for Rahul and Katie. So because you guys are, doing undergraduate work right now, what I'm worried about is, how difficult is it to get into research, because my goal is grad school and I haven't really done any research thus far. And plus, how hard is it to make connections with your professors, because you do need like recommendation letters, and I'm just kind of worried about that.
Are you a transfer student or?
Yeah, I am.
Okay, yeah, it's way harder for us. Sorry, but it's okay. I think that a lot of the professors know that secretly we're more motivated. No offense, everyone else. But I think because we have a limited amount of semesters, we're ready to get into work and hit the ground running. So definitely look into your app. There's tons of projects throughout, not just physics, but other programs too, that you can even do a project with them and it still counts as research. Look into ULab. That is a student-run sort of research thing. It's like there's a student project and then there's student mentors that are ahead of you, and you can just work on a project and put that out there. There are tons of research fairs Kathleen sets up at the very beginning of each semester, it seems like, where you can go look at research that certain groups are doing and literally meet the grad students. They are there pretty much to recruit undergrads a lot of the time. A lot of them have spaces and they want you. Don't be afraid to just talk about it. Talk about your interests. Don't worry about not having too much experience. Be willing to show up and work and learn. And that's all you can do. And they'll see it. They'll see your passion first. I think that's super important. So okay. It's definitely possible and probable if you just want to.
Yeah, and actually, maybe I can also, that was a beautiful answer, Katie. Maybe I can also comment, because I see some questions in the chat that kind of relate to this, which is like, is it possible to get to know your professors at Berkeley, and like, what are class sizes like and stuff like that? And I would say, I was really worried about this before I was coming into Berkeley. And I have to say, I think it's fine. Like surprisingly, getting to know faculty in classes is really easy if you just go and ask them questions afterwards. They're usually very understanding. Yeah, so, and as far as like getting research done, like, again, Kathleen and Anna do a really great job in making sure that we have lots of opportunities to get research. So I know a lot of like people who came in, their first year, who started doing research after 2 years, and like in their third year and fourth year. And what their strategy was that they just really diligently focused on research for like 2 years, and they did really well in grad school applications. So yeah, so I think it's very possible to get research and also do very well, just by really, focusing on all the tasks that you're given and trying to do a great job.
Okay, good, because that's something I was worried about.
Yeah, and connecting with professors, again, like you guys get to go in person, which is really great and super helpful for making connections.
It doesn't really apply virtually.
Faces and stuff, but definitely go to office hours. And I think, if you do go to one of the research fairs and just make a connection with a grad student, that is a great way in. And then by the end, you need a rec letter, you ask the professor, but that grad student's gonna like help them write it or like, you know, give them the input because they were the one working directly with you. So there's definitely ways to make connections that aren't just directly with a professor if you aren't able to, you know, make their office hours or make that kind of connection. But
yeah, and a few things to point out. So first of all, at the bottom of the chat, Anna has shared a few helpful links. Some are not at the bottom now because more questions have come in, but you should see the link for URAP, which is one of the places where research opportunities are funneled through. One thing I will point out is that most applications for research tend to be due by like the last week of August, first week of September. So if you're coming in, you might want to check same with the ULab application, which is the student-led research. It might be second week of September, but just to be safe, let's say it's the last week of August, first week of September. So if you're interested in research and if you want to hit the ground running with research, you know, come mid-August, start taking a look at these sites, see what their deadlines are, see what their applications are. It can't hurt to apply, especially if you have the time, space, energy to do so. And just to reiterate, URAP, which is linked there, is opportunities with professors in the physics department. There's actually ones listed for other departments as well, if you're also interested in astro or other things. ULab is student-led. And so this is a great opportunity for transfer students and also for freshmen and sophomore. You know, it can be competitive to get research opportunities. Some people use it as like, okay, I'll see if I get into URAP. If I don't and I get into ULab, that's awesome because then I get that student-led experience. And others want to start with the student-led experience to kind of really feel like comfortable hitting the ground running in that student environment. So you can kind of keep track of those websites for the applications, knowing that you'd be applying, you know, end of August around then. Anna also linked our supplementary physics advising website in the chat, and that has some compiled recommendations from our student community and from advising about research. Actually, and linked there, and we can add this link either Anna or Rahul. There's also a wiki page that we have for undergraduate students that provides a lot of information. It's linked in the Notion site, but we can highlight that link as well. And that has student wisdom about different kinds of things, from courses to research experience and things like that. So those are things you want, and then the research fair too. So we do a research fair. We just started doing this past year. We hope to continue to kind of improve it and streamline more positions through it. And that happens like first week of September probably too, and that would be emailed by me. And that's going to have like physics department representation. So those three things keep in mind. And if you want to look at some of the sites and check it out, and if you have questions, you can always check in with myself or Anna. So going back to the questions, what is the benefit? Oh, and a quick thing about double major, it does take some planning. So if you're really, really wanting to double major, meet with an advisor just to see how are you puzzling these courses together alongside any university and college requirements you have, alongside other opportunities. Something else an advisor can point out to you is we know what are the really time-consuming courses. Students can help with this too. But there's one that's really time consuming, the lab course 111A. So you might not want to take that course that requires so much of your time alongside your hardest math course. So there's some planning tips that could help, and you might want to kind of meet with an advisor if you're thinking of a double major. This next question here, what's the benefit of taking the 5 series? Do you cover more topics? Is it helpful for grad school applications? One thing I'll say up front, we have plenty of students who have a good foundation from the 7 series to take the courses they want to take and get into grad school off the 7 series. So it's not necessary for grad school, certainly. Rahul should be able to speak to more about benefits or other things.
Yeah, so I'd say that there's a couple of benefits to taking the 5 series. So the first I would say is at the level of community. Honestly, like you meet a lot of people that are like solely interested in physics when you go into the 5 series. That's not to say like we spend a lot of time, I guess, on the club side, making sure that people from the 7 series who are interested in physics, you know, get integrated into the community. But the 5 series is kind of just a really natural way to do that. And there's also lots of resources, because the 5 series is really hard, there's lots of resources that the department has for it. The other thing is the 5 series is hard, like for a reason. Like, I think, you know, in your first semester at Berkeley, really, or like in your first year at Berkeley, like really, you know, working through kind of challenging problems will teach you skills that you somehow use throughout the entire physics major. Like when I first took the 5 series, I was like, this is unnecessary. Like, this is so hard. Like, why are they doing this to me? And then later on, like 2 years later, like I like, you know, a lot of the strategies that I learned to like solve these problems just came up and helped me, you know, either in my research or in other classes that weren't in physics. And so I would say that's kind of the big benefit. Like, yeah, it's kind of like the assurance that if you take the 5 series, you've certainly learned all of the problem solving skills that you need to be successful. I can't speak to the 7 series, but I will say that the 7 series is also really well done. So you'll get those problem solving skills as well, but it's kind of like trial by fire versus like trial by like a gentle, you know, heat or something. I don't know.
2 quick things to point out about the 5 series. One is there's a 5A study hall that was started by one of our students, and that's a really invaluable part of the 5A experience for many students because 5A can be really, really challenging. So we have 7 series. I think there's some tutoring as well, but 5A in particular has a study hall, just like where you can go and study and get some help with that. Also, from what I've heard from students, and this is anecdotal, but maybe Rahul could confirm, 5 series is a little bit more conceptual. Someone said it's not as applied as the 7 series. It's more on the conceptual side.
I want to be careful with the word conceptual because it's very technical also. Like, you know, you do have to do lots of calculations and be very careful. But I will say that they spend a lot of time like isolating kind of the useful bits of intuition that like, you know, show up a lot in physics. So one thing that's kind of a meme is the harmonic oscillator, and they spend like 4 weeks on that, like, and make sure that you really understand the harmonic oscillator, like for everything that it's worth. So yeah.
Great. And yeah, mindful of the volume of questions and time, so we'll kind of move through these too. Can you describe what seminar classes in the physics department are like, students?
I can go. Kathy, Katie, do you have? Sorry, Kathy. Katie, do you have?
Okay.
I was thinking of an old physics advisor.
I don't know. Are seminar classes like? Does that mean physics 153, or is there actually like seminar classes for lower division that I never took because I'm a transfer?
Oh yeah, there are actual seminar classes in the physics department.
Then I don't know.
Some of them are graduate courses. I think there was once an undergraduate course for it. But the seminar classes are not really classes. So I've taken one, and you basically go, you meet with the professor on the first day. He tells you seminars are this time every week. You go to the seminars and you call it a day. Like you get an A if you show up to them. Yeah. That's it. It's a really good way to force yourself to go to seminars. But I think that's what they're like.
Okay, and if the question is about something else that we're missing with the vocabulary, just feel free to restate it if it's about like upper division courses or something like that. Next question was, are there a lot of classes that recommend Physics 89 as a prerequisite that would incentivize me to take that over the summer? So I don't think it's, and I'll put a link to the academic guide where you can see the courses, all the physics courses listed with all of their prerequisites in the chat. I'll do that in a moment. But I don't think there's a specific course. It's more knowing the mathematical physics. I guess maybe students can speak more to this. I can't think of a specific course with 89 as a prerequisite. It's more just having that familiarity with mathematical physics.
Yeah, I think you got it. Yeah, it's just it just gives you kind of a survey of all the tools that you need in physics, and it's nice to have, I would say.
Okay, and then job opportunities in physics after undergrad. One quick aside is that we have a Piazza page. So once I have a moment, I'll do the academic guide and the Piazza page in the chat. And if you have a free moment, I've put it in the chat, and if I see it there, I'll go with that. But our Piazza page is a way to anonymously or not anonymously ask questions to our sort of like student hive mind. So questions about courses, students are on it and usually respond within a few hours. So once you see that linked, I forget if it requires your Berkeley email address or something, but you could ask questions to the student community about what their student experience has been like in a certain course or in a certain club or something like this. Job opportunities in physics after undergrad, what different fields and companies would we be able to work with? So I have a few thoughts on this. I know Katie also does. So I'll hand it over to Katie first, and then it's an area of growth. I'll start there for the physics department, because physics is the career path for physics majors, there are options, and you have a great set of skill sets, just problem solving, analytical, some coding background, research skills, all these kinds of things. Because there's no direct pathway though, you kind of have to be proactive about discerning what you want and how you want to get there. So I'll let Katie speak to it, and I'll kind of fill in other things from the advising perspective.
Yeah, I think that physics actually weirdly prepares you for a lot of different fields. I recommend highly making a handshake profile when you're here. You get that through your Berkeley Career Center type of thing. They send a bunch of emails, you'll figure it out. But that's like LinkedIn, but for Berkeley people. And I've gotten like millions of recruiting emails from weirdo places. I'm like, I don't know any of this, but they're like, please come, we want you to. So there's like teaching STEM, you know, in the academic sphere, obviously go to grad school professor thing. That's sort of the track that we see the most because we have professors that did it. And so that's sort of what we see the most, but there's a weirdly large percentage of physics majors that go on into the finance sector, which is very interesting. Just our problem solving skills go into there. I personally am interested in renewable energy. There's tons of, you know, Department of Energy, so you work for the government, or city planning or things like that. I'm more interested in like waste management, water treatment, but from what I've seen, you know, it's so broad. There's on Handshake, you'll see there's like a list of on positions in there of like majors they want you to have, and physics is in a lot of weird places you wouldn't expect. There's some nonprofit renewable energy things I've seen, a ton of, you know, IBM type, you know, and Apple and Google and all these kind of like coding tech companies. Definitely they don't care if you're fully a code person. If you can kind of code, they might train you. I've gotten recruited by software engineering positions and things like that. It's very broad. So just, yeah, be proactive, engage with Handshake, engage with the Career Center. I've been to some career fairs when, you know, back when things were in person. I went to one specifically about renewable energy. So engage with the Career Center about which types of career fairs. They're not just, don't just go to the ones for physics people, go to whichever ones look cool to you. And then tell someone you're a physics major and they'll be like, cool, we started some guy on our team was a physicist. And so, you know, we're a diverse kind of bunch. We can kind of fit into a lot of niches. That's pretty much it.
Yeah, so this is something, thanks so much, Katie. And I might actually end up picking your brain a little bit more after you graduate, just for any tips you might have for students. But if you'll see in the bottom of the chat, thanks so much, Anna. So she's put the academic guide, the Piazza page that we talked about, Handshake account, which is this, like Katie mentioned, you want to create one and start seeing what kinds of things are posted there, jobs and internships and career fairs, because a lot of the information gets streamed through there. That's sort of the platform through career services for students. I also posted 2 links. One has a lot of different resources that we've compiled from the recordings of events, our grad school and career events. So recent alumni who are in different industries, what their advice are, answering students' questions. We also have like slides from career presentations that show the steps to take, like create a Handshake account, how do you update your LinkedIn, how do you focus on the analytical problem solving research skill sets that you have, how to kind of look at the different jobs out there. So there's different search engines embedded in those links that I sent, where the and some resource sheets where you can see like what companies and jobs do physics majors have nationally and also at Cal. There's different things embedded in those links if you kind of poke around. And then once you see those, you kind of want to start asking yourself, which direction do you want to head in? Do you want to beef up your coding skills and be eligible for those coding kind of jobs? Do your analytical skills mixed with your business interests make you want to lean in there? And so you do have to be a little proactive with thinking through what your interests are. And certainly Anna and I can be a first sounding board, but the Career Service Center has a lot of helpful points as well in going to those career fairs. But there is this proactive piece from your end where you know what your skill sets are. You want to keep identifying the things you like and don't like, and then kind of start even informational interviewing or kind of learning more about certain industries. So it does have to be a little bit more carved out personally than say the grad school path, which is a little bit pre-carved out. So take a look at those resources on your own time and feel free to check in with us if you have questions. Next question on the chat, oh wow, okay, a lot of questions. Okay, I'm scrolling up. Okay, we'll go through these more quickly. There's a lot. Seminar class, okay, we did that. Job opportunities, different fields. Okay, so we mentioned some of those things. Take a look at those resources and check in if you have questions about them. But we see mostly students applying analytical and programming skills for the most part. And you can take a look at the job titles for physics majors. Are there classes that are generally recommended we take the summer before freshman year? No, no. No, I think just enjoy your summer before freshman year. I don't think you need to take anything, no. I mean, some students, if they really want to get ahead in some way, and you wanted to take the Calc 1 requirements, so you have that and you can start sooner, that's your choice. But I would say it's been a tough year. You might want to just relax this summer. It's really intense. It can be intense at Cal. So I would recommend relaxing, but if you wanted to get ahead, you can look at the prereqs and see if you wanted to take one of those. Learning Python on your own could always be helpful if you really want to do something, or like they said, beefing up on calculus skills and things like that, but nothing specific you need to take unless you want to get ahead because of your own personal reason. How should you get research? I think we've talked a little bit about that, looking at UREP, ULab, and the research fair coming late August. It also doesn't hurt anytime you go to a talk, and there's actually talks called colloquia. You'll see them on our website every Monday. Those can help you kind of learn more about your research interests, but there's also different kinds of faculty talks, and some of our student groups have faculty talks and things like this. Anytime you hear something interesting or a professor, you learn on the website that their research interest is interesting to you, it doesn't hurt to potentially reach out to them or go to their office hours or send them an email just to learn more about their interest or kind of make a connection or see if they might have a research opportunity. That process kind of still exists. And I just want to mention it so it's not like a hidden process and that everyone knows about it. So you can kind of talk to your professors if you're interested in their research. Worst that happens is they don't email you back. And that happens a lot, but sometimes they do email you or you're put on their radar and they can connect you to something. I would say for the 5 series, if you've gotten a 5 on the AP exams, it's really what you have the physics background, as Rahul said. If you have the kind of calculus background that he said, you're probably a good candidate. I would say, you sound like you'd be a good candidate as long as you have the calculus background as well. It's just if you want to take it. Anything to add for that, Rahul, about if someone got AP physics, got a 5, is the 5 series good for them?
Oh yeah, I think so. For everybody that has listed their credentials in the chat and asked if they were okay for 5 series, yes, like all of you are well prepared, or as well prepared as you could be. Yeah.
Thanks. The question about, and I'm just talking quickly to make sure we get through these. We do have until 2:30, so we'll be here until 2:30. LNS physics major compared to the engineering physics major. So a few things up front. One is if you're admitted to the College of Letters and Science, you're admitted to you could only have the option for the physics major in Letters and Science, which is a BA. The engineering physics major is through the College of Engineering. So that would be if you're admitted to the College of Engineering. So if you're admitted to Letters and Science, the physics major through Letters and Science is what you're eligible for. If you want to take classes at the College of Engineering, you could, but you could look into transferring into the College of Engineering, but that's a little bit more complicated. The difference is you can take a look at their different prerequisites and setup. Engineering is a little bit more applied. They have some different courses. It's a BS rather than a BA, so a Bachelor of Science rather than a Bachelor of Arts. So some of the requirements in the College of Engineering versus the College of Letters and Science are a little bit more science and math focused, which makes it a BS. Other than that, I don't know if students have anything to say, but the main thing I'll mention is as a College of Letters and Science student, you'd be a physics major in Letters and Science. So that would be, and you can, if you look at the engineering school and want to take courses there, you would just be adding them supplementary. Any other comments from students?
No, I would mostly just say echo what Kathleen said. Like I think engineering physics majors, like the major tends to be a bit more applied. So the nice thing about doing engineering physics though is I think there are less requirements from the College of Engineering than there are from Letters and Science. So these are kind of the things to weigh.
Yeah, and again, if you're already admitted into Letters and Science though, you probably wouldn't switch over into the College of Engineering. You'd have to go through a whole process and try to switch colleges, which you'd really have to figure out if that's right for you. And also our engineering physics students use a lot of our resources and there's a relationship between the colleges. So there's that. Would an A-level, okay, so we already talked about that. That should be okay for the 5 series background. For transfer students, how hard is the process of switching from astro to physics? Is it even possible? Basically, I don't know what courses you took in community college, but the thing you'll want to focus on is, what courses you took in community college and how those compare to the prerequisites for physics. And then beyond that, it's just kind of about mapping out, when you look on the Astro website, what their requirements are to see if you'd have to make up any of the prerequisites based on what you took in your community college. So if you happen to have taken the Astro prereqs in your community college, it might be a little more seamless. If you wanted to make an appointment with Astro, maybe would be helpful, go to the Astro website just to see where you are based on what you took in community college. So it might be possible, it kind of depends on what you took in community college. I will say that usually the cadence for upper division courses is that you take 2 upper division courses per semester as a transfer student. So, you know, when you look at how many extra courses you'd have to take by switching, you just want to see how that balances out. And an Astro advisor could tell you, but it really depends on how many more prereqs you'd have based on what the Astro prereqs are and based on what you took in community college. Any other comments from Katie on that? Or?
Yeah, I mean, I have some friends who are doubling Astro and physics, but totally switching, I think, would be easier than that. But if you already had some Astro background, I don't know, like if you're coming in, it seems like the background's the same. I think the prereqs are the exact same. Coming from CC, they only have a physics series.
Oh,
they don't really have an astrophysics, at least at mine. Maybe you had a good CC, I don't know, but I think the prereqs for these majors are the same. So, but if you come into Berkeley and for one semester take all the Astro courses and then decide to go to physics, you might already be on track to get an Astro minor, and then you could get more classes and have more time potentially to you know, finish your physics degree. But again, just talk to an advisor about where exactly you're at. That's the best way to go.
Yeah, to kind of map it out semester by semester. And it might be helpful to start with an Astro advisor, but we're happy to meet with you as well if something on the physics side would be helpful. So what are opportunities for physics during the summer? Are there internship opportunities as opposed to research for physics? So I'll say up front, we did just, and Anna, thanks so much for being so good with the links. We did just start this Pi Squared program, which I think the logo always looks like it's saying Pi 2, but it's Pi Squared program. It's a funded research opportunity for physics students in the summer for research. There are funded research opportunities through certain labs, or you can get units for research. In terms of internships, we don't have any established, unfortunately. I'm working on this to try to get some partnerships or just some more pipeline kind of things for people interested in careers. But as of now, we don't have like a specific partnership such that students get internships there. We do have emails that come through. So being on our listserv, you can learn about some internship opportunities. For example, we have an alum at Tesla. He emailed me, so can you advertise this to community? We have summer internships, and then I email it to the community and you can apply. So several things like that come through and you can apply for those internships. Your best bet for internships, as Katie said, is to get a Handshake account and search for internship opportunities. Meet with a career advisor, look at LinkedIn. There's an internship fair through the career services. So it's not going to be like a set path, like, oh, we have this partnership and there's 10 internships or something. I hope something like that happens in the future. Unfortunately, we don't have that now. So it'd really be, again, being a self-advocate if you want to go on the career track. It's still an amazing thing, being a physics major, going on the career track, studying what you love and figuring out what jobs are there that really fit your interests. Our department chair has recently talked to you about how you are uniquely prepared as a physics major to solve like problems that aren't as defined. Like you're not just solving a problem that's there, you have this extra skill set. So a lot of what you're going to have to self-advocate for is naming those skill sets, identifying them and identifying your interests. And so it does take a little bit more work on your end. Advisors and career services will help, but you will have to be proactive to reach out and to find those kinds of opportunities. Anything else to add about the internship piece, Katie?
Yeah, definitely going to career fairs and things like that. You could get an internship with a company in a summer and then they'll hire you out of graduation. I have a friend who is doing that essentially. But also SULI is one of the major ones, and that's through national labs, but it is technically called an internship, laboratory internship. And that's just doing research, lab research, but for the government, essentially for Department of something or other, depending on which lab you get into. And I can post a link actually to SULI. That's a really good summer program, but usually they want you to already have research experience. But that's a good internship program anyways. So
And yeah, another thing with internships and research, again, just to plug, because I know the next question is about community, which I'll let students speak to community, but just to plug trying to get involved in something, whether it's a physics 153 class to find your transfer student community, or physics student groups and things like this. Just there is this wisdom that trickles down. I have so many students who are like, I didn't know about any internships. My friend is in this one, and she just talked to her manager and they had an internship there. So being plugged into community, you do get like some options just become available that you wouldn't have known as. Just another thing about summer opportunities, there's this thing called the REUs, which are funded research opportunities. This is research, not internship. Funded research opportunities at different research universities if you want to get taste for research in another university, and it's a cool way to spend a summer. They're pretty competitive, but we do have like a panel that kind of talks about them, but just to kind of plant that seed as another summer research opportunity. Next question is about the major community. Is it pretty tight knit? I think it really varies by students. There's a few things I can say just based on anecdotes from students, but I'll let the students speak to that.
So I will say, so I think that the physics community is pretty tight knit as far as majors go. Like, so this is relative to like bio, I think, like as an example. But I think the reason that the physics community is really tight knit is because, well, I think I don't want to comment on the transfer students, but I think it's because of the transfer course. You know, a lot of transfer students get to know each other. I hope that's true. But Katie can tell me if I'm perjuring myself. But as far as students, we have a really wonderful facility, the reading room, which kind of gives a home to all physics majors that they can kind of study in. And this is a really wonderful way to get to know people. There's also lots of ways to get involved with the community, which is why I think the community is really, you know, close. So typically you do this through clubs or by being involved with department committees. So I can say personally, the reason I felt connected to the physics community is because I joined SBS and I went to SBS events and I met a lot of people through there. And Kathleen keeps talking about how wisdom trickles down. I think in my first semester, I met someone at an SBS event, just an upper division student, and they were doing something that I was interested in. So I talked to them, and I think it drastically changed the course of my undergraduate, you know, curriculum. And I would say, you know, I'm pretty satisfied with how Berkeley has turned out. And I think the entirety of this is because I got to meet these really wonderful students at these events. So.
Yeah, I definitely think the physics 153 class for transfers is super important. I know someone who didn't take it and just was like, wait, you guys all hang out? Oh, what? I missed out. So that's really important for transfers, but also I think it's important to remember that, you know, at least as a transfer, I think pretty much all of us have imposter syndrome at one time or another in here. I think that is important to say that. Because Berkeley is pretty much putting everybody who's good at shit in the same room. It's hard to feel unique still. It's hard to feel like you're standing out still. And just, you know, trying to go to those events and feel engaged sometimes is harder. And sometimes you are isolated. And I mean, COVID just happened, so we're even more isolated. But I just want to make sure that, you know, you all belong here. You should know that. And it's okay to be the person in those office hours that's going, I still don't get it. Say that, do that thing you just did on the board for 30 minutes. I need to see that again. Just because all these other people in here are nodding along going, yes, I understand. They might not. So I think that some of there is connection, there is events you can go to make connections with our community, but just remember that it can be easy to be isolated by the feelings of inadequacy because it seems like everybody in the room is understanding something and you're not, and that is not true. And I think, I hate to be this guy, the reading room for me was not a good place to be in. Sometimes you can find people in there working on the same stuff as you, which is great, but other times, again, I'm a transfer student, I'm new, I'm just working on a chalkboard. Somebody I've never met in my life comes up and goes, interesting that you did it that way, and then just walks away. And I'm like, gonna help me or just okay. You know, so I think it's important to know that can happen too. And community is in a sense up to you. if you do go to those events, it is hard sometimes to motivate, but just know that these events are there for you. The advisors are there for you to help you find these events, to find your niche inside of this community. So.
Yeah, I can also maybe just quickly say that yeah, no, that I totally, I guess I feel for Katie's experience, because I think every student goes through some version of this. And I will say, the reading room is like a really natural ecosystem for physics majors. But as a result of that, people can be cruel, and so can people in the reading room. Especially, yeah, I don't know. I will say that a lot of the times that I felt the closest to people is when they admit that they just don't understand stuff. Like, surprisingly, like the lesson I've learned at Berkeley is that it's just okay to be dumb. Like, I don't mean dumb. I mean, like, it's okay to not understand things, because, if you're really, really, like, if you really want to understand what's going on, like, you're going to be like the least knowledgeable person in the room, like, most of the time. And then, eventually, there are less and less rooms to be less knowledgeable in, but you keep finding the ones where you're not so knowledgeable. So yeah, I will say that finding a community, like, and finding a group of people make you feel happy to be at Berkeley and make you feel like essential. And yeah, it can be hard in college.
Thank you. I'm so glad that so many sides of and facets of the student experience were shared. And I think some things to highlight too are Cal carries this prestigious weight to it. Cal Physics carries this prestigious weight to it. That's definitely there, and that definitely affects students. Every student in different ways around feeling included, feeling like they belong, the imposter syndrome stuff. So your journey as a student is definitely going to be marked, as Katie said, by finding your community, by being a self-advocate, and know that there are resources here like advisors. Like, if you're overwhelmed, you're also probably going to get overwhelmed by events, by options, by not finding study groups at first, and all these kinds of things. So advisors can be a first point of contact to be like, okay, what are your interests? Okay, this group might be good for you, or starting with this event might be good for you. So we can help you sift through those things so it's not so overwhelming, because there is a lot going on. And it is going to be really valuable to find your smaller community within physics. And so whether that's transfer, whether that's a group, I think you do want to go in thinking like, okay, let me kind of take some time and think through what that group could be, or research experience, or yeah, like getting involved with student groups, because otherwise as a default, it can be a little isolating, because it's a lot of work, and it's a lot then of self-doubt that can come up and things like that. So just know that that journey of self-advocating, of having to find your own community, is a part of things, and there are resources there, so you can have a good experience and you can be honest about the bad parts of your experience. But just know that there's people along the way, like advisors and like student clubs and transfer communities and things like that can help. In terms of, so thank you for those really thoughtful answers. In terms of would you recommend research in the first year? I'll let students speak first on this.
I mean, as a transfer, get in there, but I don't think as a freshman, no, just chill.
So yeah, I guess the big thing about research is that like, to get the most out of research, you should devote yourself to it. Like try to work at it very consistently. The way that you typically do research as an undergrad is that you meet with someone once a week or once every 2 weeks or something like that. And there's a thing that undergrads do, which is that they do all of their work right before they're supposed to meet with someone, and then don't think about it for like, however long they have till the next meeting. You don't want to do that. So I think if it varies from person to person, if you feel like, you really got a handle on the whole college thing, and you know how to, like, organize your schedule well, so that you can put consistent effort at this research, the research group that you're working in, then by all means start freshman year. But if you feel like, classes, I really want to focus on my classes and get a good foundation in physics, and it's just a lot for me right now, it's fine to take a year. Like, I think that there's very little correlation on whether you started research on your first year or second year and did well in grad school. So, or for grad school admissions or job applications.
Yeah, I would say one thing you could do is you could go to the research fair, see what's out there. You can, if you want, take a look at some of the positions if you're just curious, like come, mid to late August. I think ULab, the student-led research opportunity, is underutilized by first and second year students. That's sort of a lower pressure way to get your feet wet in research, especially without any research experience. I do think a big part of the first year is just being open to exploring things and adjusting. So more often than not, I think usually it's not always an awesome idea to get involved right away because you're still figuring out what a Cal course load is and trying to navigate your resources. If you really want to, you know the ways to. We listed them: URAP and ULab, and kind of looking through the resources. But yeah, that's a good point, Rahul, that there's probably no correlation about getting started your first year versus your second year. You just want to maybe know things in your first year as to how you might move through them. But also agree with Katie that transfer students have to hit the ground running and kind of be self-advocates in that way.
Sorry, just a quick, it's like earlier you said, like when I asked like how you can get help, and like you said that and you said how to get help, and you said that you would meet with someone like every week. Who do you meet with again? Or no?
Oh, sorry. For research, you can you basically meet with your direct supervisor in a research group. So I guess research group works because there's like a PI, a bunch of grad students, or like postdocs and then grad students. And as an undergraduate, you're at the bottom of the food chain, kind of. And so you either work with a graduate student or a postdoc. Sometimes, if the professor is very, open, you'll work with the professor directly. But the point is that you'll meet with this direct supervisor, regularly. They'll give you something that, you want to work on, and you'll give them progress updates every week. Typically at the end of your meeting, they'll say like, okay, maybe get this done next week. And you go and you tell them, what you got done, what you thought about, and they'll tell you ways to move forward. So that's kind of what I meant by.
I just want to point out also, it really depends on the research group and the type of physics you're doing. I was in a neutrino physics group, and I basically just was coding in Python the whole time. So it's like, okay, go do this, and then you do it, and then you show it to them. Or you say, I'm stuck, help me. But then I was also in a condensed matter lab where I was literally in the lab with the grad student, and we're all mixing some metals, and someone's got a blowtorch, and we have to be in person contact with that person. So you could be working more closely or less closely, and be more independent or less independent. And that's kind of the beauty of research, is that you can kind of try different labs, different types of physics to see how much of a hands-on person you are, or how much you want to be left alone to like your own devices to just report back later. So that research is very broad in that sense. You just want to make sure it's your happy place. You have the type of work environment that you want to have. And if it's not right, you just tell them and go find another research group.
Yeah, but also just another thing. So how, I guess for help in general, how for like undergrads, freshmen, and for classes, like how would you get help there?
Okay, like studying and like coursework help?
Yeah.
Okay, gotcha. Yeah, I mean, I can't really speak to lower division. If you guys want to hop in, you said there was like tutoring for 5A and 7A maybe?
Yeah, so we can share, I think it's been shared by the tutoring page. We'll share that in a moment. And also that Notion website the supplementary website that we shared, and we can sort of reshare. So you have the, some classes have the tutoring support, so we can show you where that tutoring page is. And once you come here, you can always ask an advisor, where's the tutoring page? Most classes have office hours held by the professor and the GSI. So like if you're stuck at a problem set or something, going to your tutor hours or your GSI or professor office hours could help with that. If you're stuck on academic planning or on groups to join, Anna and myself are the advisors. You'll hear from us with the intended majors email listserv, which I'm actually going to put in the chat. This is the listserv. Once you have your Berkeley Gmail or whatever they call it, Bmail, you, I'm not sure what it's called, but you can look in your groups, you can search for groups and join that group. You should be on it. We should, by having clicked that your intended major interest is physics. If you don't hear from us by say late June, just email Anna or myself. And so I'll put my email in the chat now. And Anna will put hers as well. And if we don't hear from us by late June, maybe there was some kind of logistical error. Usually it captures most students. You can also probably self-join it. So touching base with an advisor, if you kind of forget, wait, I forgot about tutoring office hours, we can touch base with you. Students really like to form study groups too. So that's a really great way. Try to find, sometimes in your discussion section, you can ask, like, does anyone else want to form a study group so you can do problem sets together? Students have recommended that, but like tutoring, office hours, and then also seeing your advisor if you have any other kinds of questions. So, and Anna and I put our emails in the chat, are helpful. If your last name falls in A through L, you'd be in Anna's caseload. M through Z would be my caseload. Does that answer your question? Okay, and so I see, David, that your question was also framed as how easy is it to find help? It can be a little challenging sometimes, so that's why definitely use your advisors and these resources as we talked about. And if you kind of forget or can't find them, reach out to your advisor. So just for the sake of time, we're going to move through some of these other questions just to make sure we get through to everything. I think the next one was, are we going to record it? Are we going to share the recording? I will share it on our Cal Week page, and if it's on like our physics main website, and it's the Cal Week page, and if you can't find it, you can email us, but we'll probably share it by the end of today or tomorrow. I'm trying to see where we were before. Okay, is there a link to make sure we're on the mailing list? I put the intended. You can self-join it probably once you have a Bmail account, a Berkeley Gmail, and if not, you can reach out to us to be added to it, but you should be able to self-add. 7 series better for someone who wants a double major. The decision between 7 and 5 is more of the other factors. I mean, the 5 series, the 5B and 5BL are slightly more units because the lab course is separated out. So it's a little bit more units and time, and it's a little harder. So it's a little bit more time, but I think the decision is more about, the other factors, like what your physics background is, your calculus background for the double major, and what your academic goals are and things like that. I have some research in particle physics and machine learning as an incoming freshman. How soon can you begin research? Some students do begin freshman year, so same process. Look at the URAP come August. Yeah, you can start freshman year. It's more rare for sure, but you would just look again at the URAB, ULab, and research fair, and we've linked those things before in the chat. And then if there's a professor whose research interest you really like, you're always welcome to reach out to them or try to talk to them or take a class with them and see what happens with that as well. But yeah, you can start research as a freshman. It's just competitive, so you just have to see what happens, but some students get it. Sorry, but going a little fast, just mindful that we have 15 minutes left just to make sure we get through it. What does physics research actually look like? What types of things will we be expected to do, and how much physics do we apply in the research? So if students can answer that, and again, just sort of mindful of time to kind of hit the high points in that question.
Yeah, I think I already pretty much talked about this, where you could be doing coding or potentially hands-on things. It really depends on the group. So just be mindful of that. Ask the grad student or the professor you're talking to about what they do day to day. And then as far as how much physics we apply in research, again, very variant, depending on which group you're in, but also a lot of the research is very fine point. You're applying one or maybe a few concepts from maybe one class type of thing, or a few background. For me anyways, it's always been like, okay, we're gonna talk about just this thing, specialized in one thing. So it's kind of like you're applying all of it, but also one specific thing you maybe didn't actually even learn in school, if that makes any sense. But I'll just leave it there.
Just to quickly, add to that, I would say your classes aren't directly applicable to your research typically, like even whether you do experimental work, or theoretical work, but often your classes are literally your way to speak the language that everybody else is speaking, like and also think at like, you know, or be able to tune to the wavelength that they're thinking at. Yeah, like I will say, like, as I've taken more classes, it's not that I've gotten better at my research, it's that everything that everyone is saying, like suddenly it's like it feels like English, as opposed to you know, whatever it was before. So
You know what? Also, Anna, if you can link our Cal Week page, because on that page we have we just had a poster session, and you can see students' posters. There's a link embedded in our Cal Week page because we're kind of featured the poster session. You can see students' posters, which kind of capture the research that they're doing, just to kind of get a sense for what research is out there. A recommendation we also hear is to apply for research experiences that you think you might like, instead of just being like, I just want any research experience, which might be a mindset you have in the beginning, but try to think of things that you might actually enjoy, because the research can really vary from data analysis to more applied and to different kinds of things. If you're interested in theoretical physics, there's also this side where we can pair you with a graduate student. We have a club in our student orgs where you can be paired with a graduate student to just kind of study theoretical physics. So there's a lot of options. The kind of main thing is, you know, reach out to your advisor to figure out what's the best for you. So Anna will put that Cal Week link, and taking a look at those posters will give you examples of different kinds of research experiences. In terms of the transfer major, switching into astrophysics, we already mentioned that you really want to meet with an astro advisor. You want to go to the astrophysics page, look at the astro requirements, and just see how your prereqs lined up from community college, and then meet with an astrophysics advisor to plan it out. It wouldn't require much logistics. You just meet with the astro advisor and see if there's a path forward that makes good sense for you. But since it's all in the same college, it should be okay. And there's a lot of overlap. You just want to check that out on the astro side. Do you need a lot of experience in research to get into physics research? As far as I know, no, not necessarily. Again, once you start looking at URAP and things like that, they all have different requirements. So that's one thing you're going to want to pay attention to, especially if you're a freshman or a transfer student or might not have research experience. Look at the requirements. They might require a certain kind of math background or coding background, but we do have some students who don't have as much experience. And we also have ULab, which again is that student-led experience, which is a great way to get your feet wet in research if you don't have experience and want to kind of be eased into it in a different way. Any other comments from students in terms of, do you need a lot of experience to get research? I think the answer is just pretty much no, and just look at the requirements for the opportunity.
I will say for certain competitive groups, like I shouldn't say there's no groups that are competitive, but for groups that, you know, to do the research, you know, you need to be able to speak more of the language. Like when I was applying, I had taken a lot of courses, and that helped me, you know, I guess stand out when I sent my email. So I guess that's the only motivation. But to get into research, I think like any research group, I think you can do.
Start from zero at some point. My
Yeah,
first
exactly.
As a transfer, my experience was just a summer program that I applied to, you know, completely cold, zero experience. And a lot of REUs, it turns out, have a special place in their heart for community college students that have never gotten to be at a research institution. So yeah, totally, you can start from zero. It's all good.
Great, thanks. And I'm just gonna go through a few of these real quick. I'm not sure what the RU Berkeley is a part of. That seems like a fun hashtag. How effective is the GPA in order to get into a master's program? These are big questions. We don't have a specific master's in physics in our department at Cal. It's attached to a PhD. GPA is valuable for a PhD. Often students tend to be over the 3.5 range, not exclusively, but it is important. But most important for graduate school, like PhD programs, is going to be your research experience and your letters of recommendation. So those are the things you want to lean into. For future jobs, usually GPAs aren't as important. It's more the experience and the skill sets that you're bringing to. But these are more questions you'd want to bring to the master's programs you become interested in. And also looking into their admissions and working with a career advisor about how GPA factors in, which tends to be not as much. Just going to kind of give briefer answers just to make sure we get these in. Ordinary differential equations and linear algebra at my community college is 89 is available in the summer. If you just search Berkeley summer sessions, it is doable in the summer. There's an online version created. It is definitely doable. I would take a look at the course description, maybe reach out to the professor or put a note on our Piazza page to see if you think it could be helpful for you. You could always reach out to the professor and see if there's a syllabus, to see if the information covered there are things that you know or could review. Students have different experiences about whether it's helpful for them or not. Study abroad programs, I have to say that those are a little bit more challenging for physics majors because you'd have to individually see if you can get upper division requirements pre-approved from universities, which can, it's just a case-by-case basis. Students who I know who've been abroad tend to take general requirements from the college in their abroad experience because it can be harder to do physics abroad. You can try to submit a course and see if it get approved. We don't have any specific study abroad programs that are approved for physics. Our students tend to stay on campus and they'll either get a course pre-approved or 2 courses pre-approved if they can, which is like a course evaluation process, or they'll do an abroad program that takes care of other requirements, and they'll try to take some summer courses or something to make up the physics courses that they've missed that semester. We don't have internship abroad programs specifically for physics as well. Again, that would be an example of working with a career advisor and trying to see what else is out there. And if we get emails coming through, we pass them along. I see Katie posted some great stuff about, oh yeah, the Sully internship. David, we talked to you about finding help. There's a question for Katie. At what point in your time in Berkeley did you decide whether to go into a job or grad school?
Honestly, I'll put my email at the end and I can give you my life story at the end if you want. Since we were short on time, let's try to get through more of these and then I'll message you directly, okay?
Sure, and just a lot of students make that decision by trying research. If you love it and you're going to be doing 6 years of research, then you would apply to grad school. If you
Honestly,
don't love it, it's not a good, yeah.
I mean, it was COVID for me that pushed me out of doing in-person research, and that was the only reason I was continuing to do it. So I just decided I wanted to stop doing academia. That's the short answer.
So yeah, feel free to reach out to Katie, or and there's other students and advisors can tell you other perspectives as well. How can you reach your academic advisors? So Anna and myself are your academic advisors. So our emails we put in the chat. Mine's just Kathleen.Cooney. Anna is A. Hilke. You see them right below. So you can just email us. Again, she's A through L last names. I'm M through Z last names. How competitive is ULab? Not sure. They have a great website that they're really responsive on. You can reach out to them and see. Usually depends on the number of mentors they have. From as far as I know, they're usually accommodate a good number of their applicants. I don't know much beyond that. So you could reach out to them to learn more, or if you can't find their information, reach out to us and we can connect you with someone in ULab. But I do know quite a few students. I think there's at least 40 per semester. It depends on the number of mentors that they get, which are upperclassmen. What's the intended major's email address? Don't do anything with that address, but it's the group that you might want to join once you have a Bmail. So once you have a Bmail account, you can go and search groups, and that's the group to join to be on our intended majors listserv. You should be automatically added once you kind of sign your statement of registration or something. I'll get the list by June, and then I'll start emailing you. And I mentioned that you can email us if you don't hear from us by June, by late June, because then we can manually add you, but you should be able to add yourself. I would send your email through your Berkeley address if you can. That just helps us keep things organized during your whole time here when you're emailing your advisors. If you took college courses, if they were articulated on a CIST, then they will automatically count as credit, and then it becomes up to you whether you want to take that course to refresh it. It just depends on how well you felt like you learned that material. But you can always take 89, so there's kind of a mix for transfer students. It's kind of up to you. I would look at the description for 89, see how familiar you are with those concepts to see if it might be helpful to you, or reach out to Katie, or we can put you in touch with students if you want to really think through 89. Or again, our Piazza page is a great resource as well, which we pasted in this chat. And then, oh great, so Rahul says check out his posters. So yeah, the posters are linked there. Thanks so much, Anna. Our research opportunities as open to internationals. All of our research opportunities here are, through our physics department. Sometimes when you apply for these REUs, these external ones, they sometimes have some restrictions, but in the physics department, they're open. Engineering physics jobs, yeah, you can get those. You might want to start with your LSBNA degree. You might want to start kind of thinking of the kinds of jobs you might be interested in engineering physics, because some students then take a supplementary course or two from the engineering department, or they might do an informational interview with someone from a company, maybe just gather information about that job and see if they're looking for a specific skill set from engineering or from programming. So you might want to just be a self-advocate in that way, but we certainly have students going into engineering jobs, and you can look at our career resources to see the kinds of companies they work for. Yeah, great resources here. There's emails. Can we post the Piazza page URL again? Okay, they did it, which is great. Thank you. That's where you can kind of ask your questions to the student. And then yeah, assist shows you where they're articulated. It looks like we're all we're all up to date on questions. So again, we will post this recording on the Cal Week portion of our website. Are there any last questions? I'll just say in the meantime that we all know you have had a really hard year with the pandemic and with all the different reckonings in our country and with remote learning. So we're thinking of you as you, discern about Cal, and as you think about coming in. We'll have that experience in mind when we, when we come back in person, just to make sure you're supported. And feel free to reach out if you have questions, or within physics or outside of physics for other resources. We're happy to help. So we'll stay on for just another minute in case there are other questions, and we'll make the recording available on the Cal Week website. Yeah, you're welcome. We're happy to help. And thanks to all of the panelists who were so helpful and so honest. Yeah, you're welcome. Juliet, feel free to speak up for the last minute if you want to.
Yeah, I just have one quick question regarding for transfers, because I'm, getting ready for, I'm trying to get into grad school. And I was looking at the requirements for upper division classes. There's about like 7 classes that you have to take for graduation, but then there's an additional 8 recommended classes for grad school. Do you have to take all 8? I'm just confused on that.
No, that's a section that we're in the process of deleting. It's really confusing.
Oh.
No, you just have to take there's 8 requirements total. There's 7 fixed, and then there's this 1 flexible upper division physics elective. And then you can take extra electives if you want. You can have your research experience, but that list, we're in the process of getting that uploaded. The one that has like math classes and things like that. Certain areas of research, you can talk to professors in that area if they recommend additional courses. But no, those extra, you only need to take we have students who get into graduate school with just the 8 courses coming in. It's really the research experience you're going to want to beef up. And any extra courses would just be if you're interested, or if the area of research you want. And it can look good, certainly, to have more classes, but we have students get into grad school with just the 8.
Right. And do you think getting a BA in physics is going to be like less impressive than a BS at, say, a different school now?
No, we have a lot of students who get into grad school. And
also, you got Berkeley.
Yeah, you're in a really competitive school.
Honestly, it's a super competitive program. It's just
and they know
not
going to work against you at all.
Know.
Yeah,
they know. So
yeah, it won't work against you at all in that way. And again, grad school is all about there's certain GPA things to keep in mind in your upper division courses, but it's really about those letters of rec and research experience, or the things you want to kind of hit the ground running on.
Okay, thank you.
Yeah, you're welcome. Good luck. Okay, great. So thanks so much, panelists. Oh, sorry, Anna.
Oh, sorry, Kathleen. Sorry, I was just going to say one more thing. So we all know that this is a lot of information for you all, and you shouldn't feel like you need to look at all these links or memorize all this information. We just wanted to provide this as like good background, kind of an overview. But as has been said a number of times in the chat and with all the panelists, you belong here. We know you can be successful. This is why you were admitted. There's so much support available for you in the department and in the school in general. So just know that we're here with you each step of the way. So in terms of, as you have questions, we're here. And so yeah, just wanted to say that. But it was so nice to have you all here and have your amazing questions.
Thanks, everyone. So I'll stop the recording now. Thanks again, panelists. Thanks to everyone here. Good luck with your discernments. Feel free to reach out, and you're welcome to leave, and we'll post this on our website, and feel free to reach out.